special sets. These are intervals here up the top. That is an interval, which means it's a continuum, okay? It's not discrete countable numbers. It's a continuum of numbers between A and B, but not including A and B, okay? This one means all of those numbers in between and including A and B. The square bracket denotes the inclusivity of A and B, okay? Round brackets means you don't include them. This means we're not including A, we are including B, and then everything in between, yeah? Okay, I think you already know this. Solid dots are denoted like that, and open dots are denoted like that. If you're on a number line, if you're including an end point, you'd put a solid dot. If you're not including it, you would do an open dot. You get that? Okay, what does this mean? All numbers from A, including A, up to infinity. You can never include infinity because infinity is not actually a number, it's just a concept. Get it? You always have round brackets with infinity and a negative infinity for that matter. Okay, what have we got here? All positive reals, all negative real numbers, and all real numbers with the exception of 0, okay? Very nice. Now, what does this mean? This is Z plus, which means, now I'll read it out to you as we go. The round bracket means the set of numbers, okay? This is the set of numbers X. The little colon means such that, okay? So we've got the set of numbers X such that X is an element of Z, which is the integer sets, and X is greater than 0, okay? That's the positive integers. Got it? Now, the Cartesian plane is denoted by r squared, okay? Which basically means sets of numbers x and y, coordinate points, okay? That's how they write it, r squared. So this says the set of numbers x and y such that x is an element of the reals and also y is an element of the reals, okay? Yes, boggles your mind, doesn't it, all this set notation, but you get used to it after a while. Okay, some examples for us to do. This is example 1. What have we got here? We've got A is this set of numbers, B is this set of numbers. We have to find A intersection B, and secondly we have to find A union B. All right, let's go. A intersection B. Now this little guy, the way I think of it, I think of him as a little bit of a fusspot. So he's got a frowny face. I just put the little eyes there to remind myself that this guy's a bit hard to please. So that means and, which means we have to include only elements common to both A and B, okay? So therefore A and B would mean, let's have a look, we've got 2 and 3 in common to both, haven't we? We have. So that's A and B. Part B, we've got A or B. Now this little guy is much easier going. So therefore I give him a smiley face with the dots there, you see, which means he's easy going, he's pretty easy to please, which means that we include all elements in either A or B, okay? Much easier to please. So there's A or B, which means everything which is in either of them, and I've put them all in order, okay? Very nice. Example 2. Okay, same sets of numbers. We have to find A with the exception of those elements in B. Now have a look, see if you can work it out. We've got all those in A. We're taking away the elements in A which are also in B, which I think means numbers 2 and 3, don't you? So therefore what would we get? We would get that. We would, because we're excluding 2 and 3, aren't we? Very nice. Pretty easy, huh? Part B, we've got all elements in B excepting if they're in A, which would mean the residual of B after you take the 2 and the 3 out, wouldn't it? Very nice. So that means, yeah, means that, 7 and 10. Pretty easy, no problem. Now we've got some number lines now, some intervals, okay? So how would you represent these intervals on a number line? Well, it's pretty easy. Part A, we've got 1 to 3 inclusive. There's a number line, and we've got, okay, you can see, can't you? We're going from 1 to 3, and they're both closed dots, which means we're including the 1, we're including the 3. Part B, we're going from 1 to 3, but not including the 1 this time. So we've got an open dot on the 1. Very nice, yes. Part C, we've got, what do we got? From 2 to 5, including the 2, not including the 5. Okay, closed dot on the 2, open dot on the 5. Yes? Great. D is 3 to infinity, not including the 3. So that would give us an open dot on the 3. And we're just denoting we're going on forever by this arrowhead here. Yes? Okay. Last but not least, we've got from minus infinity to 4 and including the 4. Okay? Here it comes. Large B. Okay? We've got everything from minus infinity up to and including the 4. Excellento. Thank you for watching and we'll see you soon.